Welcome on board, ladies and gentlemen. Today we are going to discuss about porosity. So what is porosity? Porosity is a kind of calculation or measurement which is carried out on rock samples, whereby geologists and geoscientists they can measure the total amount of empty volume spaces that we have in a rock, and they express it as a ratio with the total volume of the rock. So basically now here porosity is equal to pore volume of a rock, pore volume divided by bulk volume. So porosity is equal to pore volume divided by bulk volume. So porosity of a rock can be classified in two basic ways. So the first way on classification is genesis. Classification one we can base on genesis. When you hear genesis, you know genesis of the rock, the origin, and what happened to the rock. So under genesis we can classify porosity two forms. One, we can classify as primary porosity. Now, for example, when you look at the formation of sedimentary rocks, when sediments are carried from terrestrial environment by rivers, then transported, then they are deposited, say in marine environment or lacustrine environment. After the depositional process, the sediments they are packed in such a way that there is some pore space which is left between the sediments, and that porosity that is formed between those sediments is what we call primary porosity. Meaning that primary porosity is the porosity that a rock develops at the time of its deposition. So is the porosity at time of sediment deposition. Sediment deposition, that is primary porosity. Then the other type of porosity is secondary porosity. Now secondary porosity, after the sediments have been deposited, the sediments will undergo several changes after deposition. So meaning secondary porosity is a type of porosity now that the rock will now develop due to post-depositional forces that will act on the rock. Now those post-depositional forces are two basically. We have diagenic changes and then we have tectonic forces. So under here we have two forces. We have diagenic forces, then we have tectonic forces which will affect our rock. You know, under diagenesis, following sediment deposition, we have two forms of diagenesis. We have physical diagenesis, whereby a rock is altered via compaction. You know, compaction in sediment due to increasing overburden pressure at points of contact between sediments. When there is high pressure at points of contact between sediments, it can result into crushing of the sediments, and when those those grains which are crushed, they occupy the pore spaces, and when they occupy the pore spaces, they reduce the pore volume, resulting into a decrease in porosity. And also chemical diagenesis can also occur, for example, dissolution due to overburden pressure dissolution basically at point of contact between the grains can result into dissolution of weaker unstable grains at points of contact. They become dissolved, they go into the pore spaces. When they go into the pore spaces, they recrystallize, then they form stylolites, which occupies the pore space, reducing the pore volume. Still, in that effect, we observe that porosity has been reduced in that rock because the pore volume, the amount of volume occupied by the amount of volume which is free in the rock now is being reduced. In the other process which is also affect porosity is the tectonic forces. Tectonic forces, one when you look at, for example, if you have two plates, say under convergent, now here under convergent tectonic setting. Now at this point, when these two plates are colliding, you observe that that force that is available during collision has an effect of altering the grains, compressing, drawing the grains closer again together. And also in this way, when the grains are drawn closer together, you observe that the pore volume of the grains, for example, if you have separate grains in a rock like this, the grains will be drawn closer. So when the grains are drawn closer, you observe that the porosity is reduced. Now that one due to tectonic forces. And also during this tectonism, we observe that there is always mantle upwelling that result into magma flowing out. And when magma flows out, hydrothermal fluids which are present in the magma, they can percolate through the conduits which are present in the rock. Then they can go into the pore spaces which are available in the sedimentary rocks. For example, say maybe sandstone. When they go there, the minerals now begin to recrystallize, forming cements. When they form cement, those cements occupy the pore space. In this case, there is reduction of the volume of the pores in the rock, and in that case, porosity has also been effectively like reduced. And that case now, that's why in the petroleum industry, remember in the petroleum industry, reservoir engineers and geoscientists, they are aiming at looking at a rock sample which has got sufficient porosity because they are aiming at accumulation of enough petroleum in that rocks for commercial exploitation. So that is the first stage of classification of porosity. Then there's that we can classify porosity. We can classify porosity basing on the nature of the pores of the rock, So one way we can classify porosity again in this form is effective porosity. For the case of effective porosity, if you have your rock sample, then you have your pore spaces within that rock. Say these are my pores within that rock. Then these pores are interconnected. Let me say they are interconnected pores. When they are interconnected to one another, that porosity that rock contains is known to be effective, because of that interconnectedness of the pores in that rock, means that during production or commercial exploitation of the petroleum from, say, the reservoir, the oil will be able to flow freely under gravity. Then the other form of porosity, we have the total, or we can call it absolute porosity. Now for the case of absolute porosity, and this one basically is common in carbonate rocks, now in the case of absolute porosity, we have connected pores and isolated pores existing together in the rock. For example, now this is our pore, say maybe this is our carbonate rock. This pore and this pore are connected via this point. Then this pore here, it is isolated, and for that case, in that case we have both isolated pore and interconnected pore. In that case, now we call this total porosity. So meaning total porosity is the collection of both interconnected pores and isolated pores present in the rock. So ladies and gentlemen, thank you so much for being with me in this discussion. Please don't forget to subscribe to my video by clicking on the red button below the video. Thank you so much.